Hi, welcome back to another episode of Real-World Serverless, a podcast where I speak with real-world practitioners and get their story from the trenches. Today, I'm joined by Sandro, who is a platform lead at Hashnode, and he's also the co-author of AWS Fundamentals. Hey, Sandro, good to see you again.
Hey, Jan, good to see you as well. Thank you so much for the invitation.
Yeah, I've been reading your stuff for a little while, and I really enjoyed the infographics that you've been publishing as part of the AWS Fundamentals, and I've got a book as well. And I think I have to say it's really well written. Yeah, first of all, I guess congrats and well done. And from before we go into the book, can you say a few words about yourself, what you do, and maybe tell people about Hashnode for in case people haven't come across them before?
Yeah, definitely. Thank you so much for the kind words. Really appreciate it. So, like you said, my name is Sandro Volpicella. I live in Munich, Germany, so right in south of Germany. If you don't know Munich, you probably heard about the football club or the Oktoberfest, which just happened 2 weeks ago. Fortunately, the madness ended again. So I'm a full stack engineer. I work a lot with AWS services, with serverless services, all the serverless services you can think of EventBridge, step functions, Lambda, and so on, all the services we love. And yeah, I work as a platform engineering lead at Hashnode. Hashnode is a developer blogging platform. So you can go to Hashnode, create your blog, connect your custom domain and start writing within a minute. That's really our premise. That's what we try to do. And we're working hard for that. And like Jan mentioned on the side, I love to tinker around with some other projects. One project of it was writing a book together with a friend, Tobias Schmidt. He initially started the infographics, so he needs to get credit for them. And yeah, I wrote the book about how to learn AWS for the real world, because we really think it is worth learning it, and really think this is a cool one-time learning you can do. And on the side, I also have some side projects, Octolens, which is a GitHub actions overview, and serverless queue, which is a message queue. But I'm pretty sure we go more into detail of all of these projects soon.
Yeah, we should have enough time to cover all of those. But I guess one of the first things I want to just talk about is I saw you posted a new blog post the other day about the architecture of Hashnode. Which I thought was very interesting. I guess we can maybe spend a few moments and talk about some of the nuances, and I think it's really worth diving into, especially around some of the caching strategy that you have. I guess, do you have the architecture diagram or something ready that you can bring up so we can start to walk through? Maybe start by just walking through the life of a request as it goes into your system and all the different points they touch on, because I think that gives a really nice way to then talk about the different caching that you apply, and we can talk about some of the nuances that in there.
Yeah, definitely. So I try to make a really comprehensive overview, or really broad overview of the whole architecture. Should I share my screen? Because I think that's also on YouTube, right? So let me share my screen.
And for folks who are listening on the Spotify, you can also find the link to the article in the description below, so you can see the architecture diagram that we're going through.
Yeah, perfect. So I'm showing the blog post now. I will mainly stay on this overview. So the overview is an architecture diagram, like a really, really broad one. And it all starts with the user request. So I want to go through it as a user request happens. And first of all, we need to distinguish two things. So we have two kind of areas where users come from. We either go to hashnode.com, which is our community front end. And with community, I mean, for example, you have a feed, a typical social media feed where you see which person posted which blog post in which publication and so on. You see the different tags and you have a search about everything in your settings. And this one goes to Cloudflare. I go into this in a second. And the second one is the blog frontend. So if you visit a custom domain like blog.awsfundamentals.com or some username.hashnode.dev, you go directly to Vercel, because Vercel hosts all of our domains. So these are the two origins we need to distinguish. And in this case, we have Cloudflare and Vercel as our DDoS protection, first of all, but also as our DNS registrar and DNS system. So either way, you go from hashnode.com or blog frontend to Vercel. The next part you see is the page cache. And I think this is already a pretty interesting concept, which I just learned when I started using Vercel. Not sure if they even were the first ones to do it on like this huge scale. And the page cache is that each page is cached on the edge in Vercel's network, and the whole HTML is cached. So not just the API response or not just the database, but also the whole HTML. And this is cached on the edge. So Vercel uses, I think, CloudFront underneath. So you have the CDN, and with the edge locations and access the cache there. Vercel launched this whole thing with get server-side props with Next.js, so you could server-side render your whole page. And the nuance here was especially that you couldn't invalidate the cache via API, which is kind of a straightforward function you should have. If you cache something, you also need to invalidate it. But at the beginning of Vercel, you needed to set some time frame, so a typical cache header with SWR and a max age header. So
before we sort of move on, because a lot of people may not be familiar with what SWR mean, can you just maybe briefly explain what that means?
Definitely, yeah. So let me just scroll because I have a diagram especially for that. So SWR means stale while revalidate. And that means you have two time periods. In this example, we have the time period 5 for max age. That means the data is cached for 5 seconds, and then SWR period for 10 seconds. And once the cache is filled, what we see here over the time period of 1, there was a cache miss. After that, the cache was filled with fresh data. All other requests between 1 and 6, for example, and 1 and 5 have cache hits. So they get data from the cache, no origin is called. The SWR comes in between the time of 5 and 10. All data we call is stale data. That means the user still gets data from the cache. There's no cache miss, but you now get stale data, which means the origin will, in the background, update the data and revalidate the data. So it hits the origin, and the idea and the benefit of that is the request to the end user is still performant, it's still fast, but at the same time, you update your origin and have fresh data again in the cache. So after going to the next second to after 11, for example, you have a typical cache hit again, and then the whole thing starts again.
Okay, so does this mean that with this configuration, the value, I guess the time between the max age and the and the SWR value is the time in which a request will still be served out of the stale cache items, while a tenant will be made to fetch fresh data from the origin and replace the stale data when that data has been, when that fresh data is available.
Exactly.
Okay.
That's exactly the case.
So what happens if in this case there's no request between 5 and 10 seconds? What happens to the request that comes in at the 11 second?
Yeah, I just saw that I missed this case on the diagram. If just a request happens here, I think we hit the origin again. I'm pretty sure we hit the origin again. I would normally like to test this, but we hit the origin again and have a cache miss in this case.
Okay, so this background refreshing the cache only happens in the time between the max age and the SWR.
Yeah, exactly.
Okay, that makes sense.
And the cool thing is, for AWS folks out there, this was pretty common for Vercel, Netlify, and all of these, but CloudFront also launched this not too long ago. I think 6 months or something, they launched this functionality as well, so you can build the exactly same thing also with CloudFront.
Yeah, I think that was back in the March. They announced the support for stale while revalidate in CloudFront.
Yeah, that's really cool. But this is still a huge gotcha in my perspective, because it is a great thing to do. But on the other hand, if you can't invalidate the cache like it was at the beginning with Vercel, you still have, even if it's stale data, you still hit your origin a lot of times, and you can't have proper cache length. Because if you can invalidate your cache, you can have cache lengths of months if you know when to invalidate it and say, okay, your cache is now old, please get the new data.
Yeah, and also I guess it makes it a lot nicer when say someone push an update to their blog post. They want to see that update straight away, as opposed to, okay, now I have to refresh for a few minutes before an attempt will be made to refresh the data from the origin.
Exactly. That's exactly our use case, why why we are not a huge fan of using just this, or why it's simply not possible. And we put a lot of time into invalidating the cache, as you can see later in the architecture. Cool. So I would continue with the other steps. So the page cache follows the SWR approach. What Vercel did then, after having only get server-side props and only this time frame, is they launched incremental static revalidation. So ISR it's called. And ISR basically gives you an API for revalidating your endpoint. So you can now revalidate this cache. This was the main thing in my perspective what ISR is, and that's really cool. We have some other challenges in there with pages router, app router, and there are many, many details you need to follow to get this actually going. So this is why Hashnode here mainly still has a really short time period of SWR. And then we make use of API caches, which we will see in a second. So page cache for Hashnode is a short time period where we have the page cache.
Okay, so when you talk about the incremental static regeneration, does that can I think of it as for my custom domain, I've got a whole bunch of different pages, and I just updated one of my blog, and so I'm able to use this to just invalidate a cache for that blog piece, and everything else will still be cached as before. Is that how it works?
Exactly. That's exactly how it works. So what you do is in your Vercel API route, in the response, you have now available a method called revalidate, and you call this method with either a slash for like the root page or with the slug of your blog post, and then this blog post gets updated. So this is also what we are doing for the home page of a blog.
Right, gotcha.
Homepage so this page, for example, is ISR. So this runs on Vercel, and we revalidate it on certain events. We also revalidate the page cache, but that's the only page right now where we're doing this.
Okay, gotcha.
Cool. So the next step is Next.js. So we have Next.js servers deployed on Vercel. Again, it depends on which route you took. If you go to the community frontend or if you go to the blog frontend, you either go to the community next server or the blogs next server. And I don't think there's too much special to talk about here. So we use React in the frontend, we use Tailwind CSS, TypeScript, and Urkel as a GraphQL client. And we do a lot of server-side rendering because we, especially for SEO, it's really important that you have server-side rendered pages. And we do a lot of stuff there, but I don't think anything interesting. So if you don't have any questions on that, I would jump straight into our API caches.
So for this server-side rendering, so are they Next.js running on like the Vercel, what do you call it, Vercel functions? Is that what it's called?
Yeah, serverless functions they call it, but yeah, they run on these.
So are they running on the edge? I remember there was when they announced it, that there was a lot of confusion because they call it serverless functions, but really they are sort of function at the edge.
Yeah, there's still a lot of confusion at some point also for me. So they don't run at the edge, but you have edge functions. They run at the edge, but they have, of course, a stripped subset of node and stripped subset of what you can actually do. But the serverless functions are normal Lambda functions, which are mapped in a Next.js page.
Okay, right. So basically, these are Vercel's kind of like wrapping around Lambda functions, and then the edge functions is the wrapping of Lambda at edge. Is that how? Okay, I see. Okay, so essentially they give you a way to use to run Lambda functions without really working with AWS. You can work within the Vercel ecosystem.
Exactly. That's exactly the case. So Vercel is a great example of abstracting AWS services and making a way better developer experience and a way easier developer experience. But you definitely have some trade-offs, yeah.
And I guess these functions run automatically as if it's attached to, say, an API gateway. When a user request comes in and the Vercel says, okay, we don't have it in the page cache, let's hit the origin. And at that point, it basically invokes the Vercel function that runs your Next.js rendering.
Yeah. So if you go from this direction, if the page cache is missed, so if there's not a cache hit, then you execute the serverless function. Yeah. Then the serverless function is executed.
Okay, gotcha. I think I understand now.
Yeah. So it gets quite complicated. So web development itself gets quite complicated, to be honest. But yeah, the basics are still the same at some point. Okay, so Next.js, the next point we have is API caches, and I think this is where it gets really interesting. So we have API caches Stellate, which is an amazing product. It's a GraphQL Edge cache, but also a GraphQL API overall tool for observability, for alerts. You can have a developer portal and stuff like that. But the main thing we use and leverage here is the Edge cache. And we still have the kind of Vercel cache. So for serverless functions, you can also cache the response of a serverless function. And because of legacy reasons, we still have it here. And I think this will be clear in the API function, in the API section, because there's still kind of a mess in our APIs, I have to say.
Okay, gotcha. Yeah, I've seen the Stellate before. I guess before they rebranded, they were called Graph CD. I think it was a GraphQL CDN or something like that.
Graph CDN it was, yeah.
Yeah, that's it. Yeah, yeah. They do have some really interesting features. I particularly like the kind of like observability, and also they give you that that throttling based on the complexity of the query.
Exactly.
Sort of, based on the depth, on complexity of the query, so that you don't have to implement it in, say, AppSync. I actually used it in front of AppSync. You have to do some work to make it work because of some of the custom the sort of custom types that you have in the AppSync, like JSON or datetime and things like that. You have to kind of declare them when you upload your schema to Graph CDN. But yeah, it's a really nice service.
Yeah, it is. So the developer experience is really nice. The support is amazing. The founder Max is amazing because he lives in this whole ecosystem for a long time. I think he sold his last startup also to GitHub. So I believe he knows what he's doing, and they're really a great product. So we use the rate limiting, for example, as well, which is not mentioned here. But yeah, that also saved us a lot of custom implementation.
Right, gotcha. And then you've got I've noticed that in your GraphQL API, you've got the logo for API Gateway in there, not the AppSync.
Yeah, yeah, I knew that it was coming. That was the first questions I got on this blog post is, why do you use API Gateway, Lambda, Apollo, and not AppSync? And the main, it has several reasons, I believe. So the main reason is the team where we've created this. I didn't initially build this API, was just much more familiar with Apollo and Lambda. So, and I think this is also something we always need to think about if we make these tech decisions, is what is the actual skill of the team, because AppSync can be quite special. And and back then there was no JavaScript resolver, so there were like direct VTL resolvers, and people get mad with this because it is quite weird if you see this the first time. The cool thing, what I have to say, since working a lot with Apollo and Lambda, or mainly Apollo, is that you have an executable schema and that you have these custom directives in your schema. So you are much more flexible what you can do with the schema and with this whole plugin world you have in Apollo. For example, we can have directives on each field where we say, kind of these directives we have in Amplify, but where you say, for example, you require auth for a certain field in your post. There are some fields where we don't want to expose without authentication, and then we have certain scopes on these fields. And this is, the developer experience can be quite nice with Apollo and with Lambda. So I don't regret it that much, but yeah, if I need to rethink the decision from ground up again, I'm also a fan of AppSync, so it would be a hard decision to take.
Yeah, and I guess with AppSync, you get some of the caching capabilities out of the box, and it can also be quite granular in terms of how you cache things as well. I mean, you can decide which of the resolver layer level gets cached, which ones doesn't. But I guess the thing that I'm most interested in, I guess, understanding is in that trade-off is, well, when you got API Gateway and Lambda, there's an additional concern you have to think about in terms of cold start performance. And I guess for Hashnode, if you've got a steady traffic, it probably isn't going to be an issue, especially with all the caching and stuff in front of it. So you're probably not going to be experiencing huge spikes where you're going to see lots of cold starts all at one go. I guess maybe at this point, is it worth just talk about what sort of the traffic pattern, what sort of throughput are you seeing on your APIs and on the whole system?
Yeah. So two things. First of all, the AppSync caching. Yeah, the caching is good on the one side, but it's just a server caching, right? So it's not an edge cache. It's still just cached on the server. So we would need something like Stellate anyway. This is also, yeah, one of the things I would love to see with AppSync.
Okay, right. Wait, hold on. Why would that matter? Because the page cache are on the edge. Absolutely, that makes sense. Closer to the user, because it's the final rendered HTML. But then, if there's a cache miss there, you're gonna go into the Next.js function, which is not on the edge. So whether or not you need the edge caching for your API, I guess I'm not seeing why that's important.
So we would here make that's true. So we would here make a round trip anyway.
Yeah. So because once you get to the function,
something,
once you get to the function, you probably don't need the edge caching because you're not situated close to the custom anyway. So you really just need a standard cache, maybe close to your infrastructure as opposed to on the edge.
Yeah, that's true. Missed that, but you're completely right. Of course, we have the whole round trip. Once we miss this cache, then we need to go back to Next.js, and this is based in the US. So
right.
So we don't have a huge benefit then there.
Yeah, so I guess if you do switch to AppSync, then potentially you can switch to using AppSync's caching instead of Stellate. But I guess Stellate is still going to give you things like rate limiting and some protection against really deep invalid or malicious attempts at invoking your function with really deep query stack.
Yeah, exactly. This is so also the whole observability part of Stellate is really interesting, and that's the main thing we used Stellate at the beginning, to be honest, because we just migrated from a REST API and didn't understand anything because we had no monitoring before that. So Stellate was a huge help here. But it is true that the whole round trip, this is something we need to overthink probably as well.
Okay. Yeah. Sorry, I stopped you earlier. So please continue.
Yeah, no worries. So APIs. I think the second question you ask is about the traffic pattern. And what I'm also a bit amazed of is we do have a quite steady traffic pattern, because you asked about cold starts. Of course, we see cold starts, but all our lambdas are like warm for the maximum time. We see this a lot, that we have like the same log streams and the same containers 15 minutes warm in one lambda. So we don't have a huge issue with cold starts, especially with our caching layer in front of that. But this was the main concern with Apollo, and it is one of the main concerns, of course, that you have.
Yeah, gotcha. I understand. And also, I guess nowadays with the active, the proactive initialization, you're going to see less and less of cold starts just in general anyway. And because of all your caching layers in front of things, you're not going to see big spikes that's going to trigger a lot of cold starts in one go. That's kind of the area where, okay, that may be a bit problematic. If you got someone posts a really popular blog post, lots of traffic comes through, you get a big spike, and that's when you're going to see, Lambda cold starts happening all at once. But if you've got caching in front of it, then I think you should be protected against those particular situations.
Yeah, so we have this with like Hacker News, especially Hacker News drives insane traffic.
Yep.
When a post goes up there, we do see a spike, but we rarely had any problems with that, to be honest. So I'm also amazed by that, because that was my main reason for using AppSync. And still the direct resolvers now with JavaScript resolvers even is a great thing to do. So if you have direct integrations, but like I said, the whole development experience and knowledge of the team is also something to consider here.
Yeah, absolutely agreed.
Cool. So and what I've mentioned earlier with MES and API. So remember, we're still in early stage startup. So we do this step by step. What we have is we have one legacy REST API, and I'm not sure if you know what this icon means. This icon means is the service Lightsail, and not an AWS service I prefer or love working with, because it's like outside of this whole AWS scope. You don't have IAM, you don't have you're just outside in a third-party service, basically, but you pay via AWS. And our legacy API runs there. This is a JavaScript API, which is pretty hard to maintain, so we try to get rid of that. But we also have this API. And the last part we have as API are next API functions. And This is pretty interesting because this was, in my perspective, one of Vercel's main points. So what we talked about here, get server-side props, you have all of these API functions now in the API layer. So if you have pages /API/hello world, this is exposed as an API. And at some point, we started migrating to these API functions. And the thing is, if you have 2-3 repositories and your API functions everywhere, you will feel the pain points very, very fast by not having a centralized API. And this may work for some side projects, but the larger your organization gets, the harder it will be to really understand what is happening where, to have a centralized caching and all of that. So this is also something we try to get rid of. In the end, we just want to have our GraphQL API, and all other APIs should be in there.
Okay, so let me see if I can understand this. Once you get to the Next.js function that's doing the server-side rendering, you need to call your API to get, I guess, the blog post, the title, description, bunch of other things that need to get all the information you need to get to render the page. And then you go to Statelate as the sort of the edge layer. And then that then goes into your GraphQL API in running API Gateway, or your Analytics API, or your legacy REST API. So do you ever have that one query that goes to Statelate and then have to go to the GraphQL API and maybe some other API? Because then I think that the request is going to be like the resolution is going to be interesting, how you break that request up into REST as well as GraphQL requests to the backing, the origin APIs.
Yeah, so Statlet is only connected to the GraphQL API. Probably should have an error here. Statlet is only connected to GraphQL API, nothing else. So Analytics API, I just put this in for completion. This has nothing to do with the business context. Legacy REST API, Next API function. This is all other than Statlet. Let's say this is mainly working. So especially the Next functions are mainly working with the Vercel cache.
Gotcha. Okay, that makes sense now.
But yeah, how that works, get server-side props and doesn't need to call an API. So we have some services then, which are doing the same thing, getting some data, for example. But we also have Next API functions. And it gets especially confusing if you have blogs and community. You can imagine that we have some certain data which is shared between them. And then we have kind of the same APIs because 2 teams build them, but we have different filters in there. So you see a lot of pain points the more you grow with these API functions. They sound nice at the beginning, but having a centralized API and a team that takes care of that is really the way to go in my perspective.
Okay, makes sense.
Cool, and all of these APIs are emitting events. So if we are emitting events to EventBridge, we use a lot of EventBridge. We have, I think, around 70 events. We come to the async processing in a second. And then our data stores are, so everything is, of course, persisting data. Our data stores are mainly MongoDB deployed on Atlas. So we have a MongoDB instance that runs on Atlas with all our blog posts, with all our publications, users, and stuff like that. Then we have Redis. Redis is on Upstash at the moment. Yeah, kind of mixed feelings about Upstash, to be honest. So not a 100% best experience I had in the past. But yeah, in Redis, we have some caches, some logs, basically, but a lot of our personalized feeds. So our social media feed, we have pre-calculated in Redis for all our daily active users, because this can get quite a heavy computing. And since MongoDB is not serverless at all, we would bombard our database. So we pre-compute them for each post published, for example, for each daily active user, that they have fast access for that.
Okay, so is that going to be using like a sorted set or something like that, so that you got like a time or order the list of blog posts?
Exactly. We have a sorted set there. I have to say I didn't implement it. I just built the architecture, but we have a sorted set in there. So, or a step before, once a post is published, we emit a step function. We have some spam protection in front of that, but after the post is good, we emit a step function. This step function is then taking care of seeing, okay, is the page cache up to date? Because the post cache in Redis, so are all posts in the cache on Redis that you need to take care of, because you need a huge pool of posts. Then are user metadata available, because our personalized feed also looks at stats like following, how many posts has the user published, and so on, to rank it. And then we rank the posts for each user, and then we put it on Redis. And each user has its own set, so its own key in Redis. And then we have like a sorted set with a ranking score with the post IDs in there. We have a blog post about that. I think that's also really interesting. I can link you to this as well. Here it is. I send you the link later, then we can put it in the show notes.
So if you're listening or watching this, you find the link to that article in the description below.
That's cool. So this is what Redis is doing. On the other side, we have Firestore. Firestore is holding all our drafts for fast saving. This is also mainly, it was a very early decision in Hashnode, so not necessarily needed, but Firestore has really fast access, really fast database where we can save all our drafts, because once you type 2 words, then it's saved. So we have a lot of read and write requests there. And yeah.
It sounds like that's something that you can probably replace with Redis or something like that, so that you have, again, a really fast read and write access and quite scalable.
Yeah. I think the initial idea of Firestore was to use the real-time database with integrated WebSockets, because this is quite a nice product. But in here, we just use the normal database for Firestore. So this is not really needed, but it's, let's say, very deeply integrated. So at that moment, not worth the effort to get rid of it, but it would definitely reduce some complexity. But saying what you said with Redis, having a draft in Redis would be possible, but we had with Upstash 2 times already the case that we lost all data. And for us, it's fine because we have just stateless data there, but I think they mentioned that you could use it as a kind of database and really persist data in there. And yeah, we had the case that 2 times errors from their side happened, and we just lost all of the data without any notion. That was kind of bad, to be honest. So I wouldn't do this on Redis. This is
Upstash lost all of your data twice.
Yeah. So yeah, I feel bad for hating them publicly on a podcast, but this was really cost us a lot of time. We had a lot of issues with figuring out what is actually happening. And then in the end, I think somebody tried to upgrade our instance manually, and yeah, unfortunately lost all of our data, which is not too bad because we use it as a cache, right? So we just hit our origins again, but we can DDoS ourselves like that, which is also not too good.
Yeah. Okay. I didn't realize the Upstash had problems like that in the past. Okay. Good to know.
Cool. Yeah. And I think this is like the main bottom layer. So I hope this is a bit understanding if you don't see it in your YouTube video. And the top layer is the asynchronous processing. And this is kind of the whole backbone of Hashnode. And what I said earlier is we emit events from our APIs. And we have some example events. We have 70 different events, but most of them are, for example, a user publishes a post, a user deletes a post, a user likes a post. So all of these events hit EventBridge. And then from EventBridge, we have consumers behind them. We have, I think, 40, 50 rules about, and these consumers do various things. One consumer, for example, is invalidating the caches. So Stellate cache and page cache, the homepage cache. Another consumer is setting up domains on Vercel. Another consumer is sending out newsletters because we offer newsletters for every blog. So all of that is then really happening async. And this is really nice with EventBridge, I have to say, because you have the serverless orchestrator. You are very, very flexible in using your consumers and using your destinations. And yeah, our main consumer here is Lambda, and on failure destinations or DLQs for error processing, and Lambda for like all of the business logic, and that's working out pretty well.
Okay, yeah, you mentioned earlier with that you're using step functions. So step functions just for using for sort of like calculating the score of the blog post and then to distribute the blog post to the followers' personal feeds. Is that using like a parallel state or some kind of a dynamic parallel map state?
Yeah, exactly. So we first get all active users, which is also saved in Redis. If you access the feed twice a day or 3 times a day, we count you as an active user for now. So we add you to a set, and then the step functions iterates over all of these active users and calculates the post in parallel for these active users. I think we reduced the concurrency at some point because we were growing a lot. So we reduced the concurrency that we don't have all lambdas at the same concurrency. But this is one use case we use with step functions. Yeah, I can tell you, I think 2 other use cases if you're interested.
Yeah, sure. I'm a big step functions fan, so
Yeah.
let me know what other things you're doing.
Yeah, me too. So I think one really cool use case is our newsletter import. So as a blogging platform, we also offer that you have a newsletter for your readers. And often people come from various platforms, self-hosted newsletters, Substack, and so on, and they want to import the emails. And importing emails is always a bit dangerous because you attract many spam people who just bought some email lists and also often think this is legit and try to upload 40,000 emails. And we use step functions here to, first of all, start the import. And if we are over a limit of 5,000 emails, for example, we have a wait task token. So we stop the step function, send a Discord notification to one of our product managers and say, hey, this user tries to upload 40,000 emails. We upload this list to S3 and we give some examples and say, hey, please contact this user. And we have some buttons, a approve button and a decline button for saying, okay, is this user allowed to do it or not? Manager is doing his stuff, validating it, and then clicks on approve or decline, and the step function is then doing their things. And yeah, implementing this with step function was super easy, and without would be quite a hassle, I believe, to do this. So that's
those kind of
amazing case.
That kind of use case is perfect for the callback patterns in the standard workflows.
Exactly. So.
And I guess that I guess you mentioned earlier that you guys are thinking about maybe potentially moving away from Firestore because you're not really using the real-time database feature. And if you're going to do this again, you may use AppSync instead of API gateway and running Apollo in the Lambda. Are there any other things that if we have to redesign this whole architecture from the ground up again for, say, a new startup, are there any other things that you would change, that you would do differently?
The architecture from asynchronous processing I wouldn't do differently at all, because this is mostly what I've built up together with platform team when I joined Hashnode. The other things, it is hard to say. It's easy to say now, but it's hard to say when you're growing and like pivoting your business model a few times. What I would do differently is definitely TypeScript and rethinking about using much more TypeScript and having a GraphQL API from the beginning and not like these several APIs. Because if you look at front-end and React code, you come into hell at some point if you don't have proper TypeScript, in my perspective. And using Vercel, I think we were able to move really fast with Vercel. But Vercel has some down points, which is definitely, it is costly, so it is expensive to use it. And also with this whole, you easily build some API functions, you don't have revalidation of caches here and stuff like that. You are also a bit restrictive and less flexible. So this is something I would think of. And the third point is the database. So we have MongoDB on Atlas, and MongoDB on Atlas is really the main case, which is outside of the whole AWS environment. So it gets pretty interesting how to test things, how you set up infrastructure as code. MongoDB Atlas, I think Alex Dupree has an amazing post from 2019 about serverless databases, where he also recommends not using MongoDB Atlas, if I remember that correctly. And because you have kind of a managed database, but kind of not, because you need to take care of auto-scaling. You still need to use things like connections, and our main incidents are always due to connections because we have serverless consumers, but we have a connection-based database, which doesn't make sense. So I definitely would not use MongoDB Atlas. Developer experience is nice. You have MongoDB Compass and all of that stuff. You have aggregation pipelines, but it's not, in my perspective, not worth it to use it like that. So I would use DynamoDB, or even now with these new databases as PlanetScale, Superbase and stuff, maybe even a normal SQL database with some good ORM.
Okay, yeah, that makes sense. The fact that you have the managed connections, that's always going to be tricky when it comes to working with Lambda, because Lambda can scale so quickly, so broadly. And let me see if I can find that blog post from Alex Dupree.
I find it because I saw it, I think, yesterday.
Okay. I see the one that he posted about SQL, NoSQL, and Scale in 2020. I don't know if it's the same one.
I think this one, choosing a database for serverless. Yeah.
Okay.
And there he distinguishes between server-based relational, so server-based SQL, server-based NoSQL, and then basically DynamoDB and Aurora V1. And yeah, I get the points he makes, because with like NoSQL, with NoSQL server-based, you have some of the cons, but not really the benefits what DynamoDB gives you. So I'm not a huge fan of using MongoDB like that, but it's always easy to say now. 5 years ago, 6 years ago, it was probably also different.
Yeah, you learn with experience by making mistakes.
Exactly. So yeah, I've learned by solving a lot of incidents and trying to understand why there are so many connections.
Right. Okay. Great. Let me just put that in the show notes as well, so that you guys can, so that everyone who's listening can go and read it afterwards as well, because I think that is still very much a relevant advice. Okay, so that's the Hashnode architecture. I do want to also ask you about your books as well. I guess AWS Fundamentals has been out for a little while. I saw you released the version 2 maybe a couple months ago. That I got an email because I got a book. So I guess what's the big idea behind the AWS Fundamentals? I mean, personally, I really love the infographics. Why did you write a book, and what's this? Who is this book for?
Yeah, that's a really good question. I wouldn't say I always plan to write a book, but I'm really proud of that. So the idea is, first of all, I wrote the book together with Tobias Schmidt, so who is like the inventor of all of these infographics, I would say. And we met early on when we both created content on Twitter and in the internet about AWS. So we're passionate about the same things. At some point, we had a few calls just rambling around. And we said, okay, we want to join forces at some point and create content. And we started our blog back then, the AWS Fundamentals blog. And we saw that the same questions appear over and over again. So we see from our audience, people are still confused how to use SQS and Lambda, and when should they use SQS, SNS, and all of these default questions you see at some point. And there was no easy way for them to learn it. And we thought about how we've learned AWS, and we were really lucky by learning AWS both in our bachelor studies when working for a company. And I was at BMW at this time, for example, and we had colleagues from AWS, and we had amazing colleagues in the departments. They taught us everything, how to use serverless, how to use AWS. So we were really fortunate, but I don't think everybody's fortunate like that. And we were a bit annoyed that the first thing you do if you want to learn AWS is do a certification. This is why we bash a bit on the certifications here, because I don't think it is necessary if you want to build something on AWS that you have a certification, because you learn something there, but you learn it, you try to remember everything the question says, and you don't really learn how to work with it. So the main idea was teach AWS with real world examples, and especially with visuals, without relying only on certifications. I think that was the long point why we wrote this book.
Yeah, I totally agree on the point about certifications. I think for a lot of the newcomers, I do recommend them to study for some of the I guess what do you call it? Solution architect,
solution architect associate.
Yeah, associate level exam. I think it's good to study for that, because the study material covers a lot of the common services. So it's really good as a way to give you a kind of a guided tour of the AWS landscape. But it's not good. It's not useful for actually building. It's like learning to swim by, watching a YouTube video or something like that. You really need to just get into the water and start paddling.
Yeah, exactly.
So I think certification is not useful for that, and it's also not useful for really just getting a job. I don't know of any employer who puts any weight behind the certifications. Maybe if two candidates are identical in every single way, and you have only one job opening, maybe you look at certifications as potentially, okay, some kind of differentiator, but I don't know of any employer who actually puts any weight behind, okay, we're going to hire this person because he's got the certifications and some other person doesn't.
I think if you want to be, if you're a consultancy AWS partner and you want to become an AWS Gold partner, then you need to hold XYZ certifications. And this is really when you need to do a lot of certifications. I also did them in my first job because I thought, okay, it doesn't hurt, of course. But yeah, in the end, I go to Wiz Labs, do mock exams, know them by heart, and only pass it like that. So not sure if that's the true approach.
Yeah, I think most of the time though, you just you just get hired by a consultancy and they just put you through the tests. You just have to do the test to get the certifications, as opposed to being hired because you've got a certification. Because getting a certification is not hard. It's like you said, a lot of time you're just doing some of the mock exams and then memorizing some of the answers, because it's all multiple choice anyway.
Exactly. Yeah.
Okay, so yeah, AWS fundamentals. I think it's it's a really good job you guys have done for the book, and especially for the infographics that you've been sharing as well as part of the package. I think things like that. I think it's really good to have everything just at one glance, even though it's a lot of text to read. But at least it's all in one place. All the big concepts. It's a lot easier to sort of save that than to flip through, I don't know, 4 or 5 different pages and the multiple blog posts that cover different, or maybe you want to just go through the AWS documentations, like the 130 pages of it, to get the key points you need for a single service. But yeah, you also mentioned you've got a new book as well that you've been working on, all focused around the CloudWatch.
Yeah, exactly. So the second book, we thought long about what we do next, because AWS Fundamentals for us was a success. We sold over, I think, 1,400 books at this moment. So it was really, really nice. And we wanted to go more deep into some topic, and we thought about doing something hands-on. And then we thought about, okay, there are a few services on AWS that everybody uses, but they're at some point either not well educated online, or pretty hard to understand at some point. And this is when we came up with doing a CloudWatch book. Because at Hashnode, for example, we only use CloudWatch for observability and monitoring. And I would say we do pretty well with that and pretty good with that, on our scale at least. And we saw during our freelance jobs and also our normal, let's say normal jobs, we saw many people creating an AWS account, and before creating the first budget alert, buying some third-party provider. And they pay enormous amounts of money, especially if you go to huge enterprises. They pay a lot of money to some third-party providers, which is not always necessary in my perspective. So there are cases where it's necessary, definitely, but not to starting out and not without even understanding how CloudWatch works. Because they often had use cases that were fully covered by dashboards, alarms, and log insights, for example, and they didn't need this whole suite of other things. And this is what we want to do. So the CloudWatch book, it's not officially announced yet, but we will announce it soon, probably when this episode comes out. And the idea is to have not just a book this time, a book in infographics, but we also want to have one project which covers from a next application, so from a front-end application up to a backend, an API gateway, up to WebSockets, DynamoDB. So we want to show you the whole suite of how to use CloudWatch, how to trace requests between each other, and also how to instrument it with Terraform and probably CDK. We're still in the decision about that. And to give you a whole suite of an application, how to do this, because I think it's good to read, but it's even better if you have some implementation example, how you can use it, how you can patch your SDKs and stuff like that, that you see your requests everywhere.
Yeah, that's an interesting topic. Something that I have to say I'm slightly in disagreement with you, because I've done a lot of that work myself, and I've spent a lot of time trying to master CloudWatch. And honestly, it's just a lot easier, and it's probably end up being cheaper to just pay for a service that's provided that the price you pay is somewhat reasonable. Because whatever you save in terms of paying a vendor for better tooling, you end up just spending a lot of time just implementing what that vendor gives you out of the box. I spent a lot of time building the whole Lambda power tools for the zone. We do a lot of the self-distributed tracing stuff, the tracing correlation IDs, automate a lot of that through CloudWatch logs. But nowadays, I almost don't do any of that because I just use the Lumigo for pretty much all of it, and you get all that stuff out of the box. And there's also a lot of costs associated with CloudWatch for alerting as well that you get out of the box with a lot of vendors nowadays. So I'm really interested to hear to read about the book, when it comes out. But I have to say I'm probably on the other side of the fence where
Yeah.
I prefer to find a vendor that does the job really well and hopefully not too expensively. I think on that, if you're going with Datadog, then you might find that it's quite expensive, especially for serverless, because of the way Datadog's pricing is structured around number of resources. So if you want to follow best practices for Lambda, having single purpose functions for that's one thing at a time, you're going to find your costs blow up pretty quickly. But I think there's also a lot of other vendors that can do a good job without costing an arm and a leg.
So don't get me wrong, I also understand the usage of these tools. I talked, I think, 2 days ago with Boris Tain from Baseline. Baseline is amazing. I love the product because I loved earlier when I simply worked on containers and typical Java Spring applications. I love to use Kibana and the Elk stack because the observability was really easy. But we don't think we should jump straight in and even understand to some extent CloudWatch, because what often ends up is that you pay double. What I see at other companies, they have CloudWatch and they have huge CloudWatch bills, don't do anything with them because they put all the logs then to some Datadog, New Relic, some other vendor, and pay double the price without even understanding what they can do. And like I said, sometimes they have such easy use cases that I think at least to understand it and to understand how to instrument it is crucial for making this decision, because you don't always need it. And especially as a manager, we had some managers reaching out to us after putting more content about CloudWatch on our blogs. They also said, yeah, exactly the same thing, that they are not sure if they need these huge tools. But Lumigo is amazing, Baseline is amazing. I love these tools as well. So don't get me wrong on that.
Yeah, I think you should learn. You should always learn what those tools can do, and also just the tools that comes out of the box with CloudWatch. You should definitely learn them, but whether or not there's nothing wrong learning something and then deciding, okay, I don't want to use it, or it's not right for me. I think you should always learn, especially for something that's out of the box with AWS and you're invested into AWS. But I think for a lot of companies, AWS do run into, CloudWatch do run into limitations really quickly because it's a regional service. And even though you could do, cross-region dashboards and all these other things like that, the way to do that, the process of getting there is so clunky that it's just not worth the while, I think, a lot of the time. But I take a point. You should definitely learn it. And personally, I have. And after learning it, I've kind of reached the conclusion that a lot of time it's just easier to use something else. And luckily nowadays, you don't have to pay CloudWatch costs if you don't want to, because with Lambda extensions and the whole telemetry API and things like that, there are ways. I wish they make it easier, but there are ways for you to just skip CloudWatch altogether for your Lambda functions for those getting your logs and stuff like that. But I have seen that a lot as well. People paying double for processing and storing the logs in CloudWatch and then forwarding them to Logs.io or whatever log aggregation platform. And I've done that multiple times before. I've got blog posts from, I think, way back 2018 or something like that about how to do that with Kinesis and the Lambda functions. But yeah, it's nowadays luckily, the tools are getting a bit better, but most people don't know what those practices are, what those tools are still. So yeah, I'm looking forward to seeing your book come out. Hopefully by the time this episode goes live.
Yeah, thank you. Can't promise it, but I do my best to to do that.
So we've got a few more minutes left. I do want to just also ask you about the other project that you mentioned earlier as well. I knew of Serverless Queue, but I didn't know about Octo Lens. Can you tell us anything about that?
Yeah, definitely. So both of them are side projects of mine because I love to tinker around with different projects. And serverless queue is an HTTP API for a message queue. So you're probably not the best target customer for that because you know how to use SQS and you know how to use AWS. But there are many startups out there, and I saw this while joining Hashnode, is that many startups out there don't have a cloud engineer, don't have dedicated AWS knowledge, and it's start on Vercel, and they have this huge application on Vercel and start on Vercel, but at some point they need some background processing, they need some async processing, and I think every application reaches this point. And what is happening often then, that some developer who used Vercel is creating an AWS account and is just overwhelmed if you haven't used AWS before, you have IAM, you have budgets, you have unlimited costs, you have different accounts to create some. And in the end, what do you want to do? You want to queue something. You want to create in the background an audio version of the blog post. This was the example why we initially started using AWS. And while I onboarded some of our developers on our whole AWS platform, I thought, okay, this can maybe be easier for some customers. And this is when I started serverless queue. It is an API where you can enqueue requests and you enqueue a message. And this message contains a target. And in the end, you put it on a message queue and the message queue goes back to your API, whatever API your target is. Often it is the Vercel function again, which handles that. And all of that wrapped into a nice SDK and into a nice developer experience. This is what we try to do. You don't care about the infrastructure, you just care about the code, what everybody promises. And that's what I started, I think 1.5 years ago. We have 500 users by now. We made a too nice business model, I would say. I wanted to have everything serverless. So we have a usage-based model where every request is counting and you don't have a minimum subscription fee, which is quite interesting from a business perspective. But we saw a good adoption. We have about 20 to 30 paying users. So for us, it's a really nice side project that we are doing at the moment.
Yeah, the usage-based pricing, to succeed with that as a business, you really need to scale. That's something that I spoke with, I think it was a Slobodan way back, or I think a couple of years ago, about FinOps. And one of the things that we came up with was, okay, yes, usage-based pricing is great, but if you want to do this as a startup, you really need to hit the scale pretty quickly. Otherwise, you're not going to make money from these services.
That's true. Learned this the hard way, but that happens when a developer who wants, this is the pricing I would like to have from other tools. I understand why no other tool has this pricing.
So I guess for your next startup, you're gonna have to think about use some kind of a tier-based pricing, subscription-based pricing.
Yeah, we probably changed that anyway also for serverless queue for then upcoming customers.
Sure. I guess also in that case, I guess the only thing that's left is OctoLens. I actually haven't seen that.
Yeah, I haven't talked too much about it. I did this together with Yannick, the other platform lead at Hashnode. Probably read about him on Twitter. And it is a pretty small side project. What we saw a lot, we use a lot of GitHub Actions for all our AWS deployments, for a lot of app deployments, different tests for things you use GitHub Actions for. And we never knew, we always got this alert, hey, you run out of GitHub Actions, you now pay for the GitHub Action, but we never knew which repository is using it, which workflow is using it, and all of that. And so we made a simple dashboard, simple UI for that. And turns out it's really hard to work with GitHub APIs and with paginations and figuring this actually out. So I know why there is no dashboard for that, but I know that GitLab had something for that, and we were missing this on GitHub. So this is what we've built. It's currently for free out there, so you can test it out if you want. You can connect your GitHub account, your different organizations, and see if you like it.
Okay, great. You would find the links to that to both serverless queue and OctoLens in the description below as well. So Sandro, I want to thank you again for taking the time to talk to us today, and I want to wish you the best of luck with all of your projects, and look forward to the CloudWatch book coming out.
Definitely. Thank you so much for the opportunity. I really love your podcast and love your guests. Really honored that I was part of it. And thank you, Jan. Talk to you soon.
Thank you. Take it easy, and goodbye, everyone.
Bye-bye.